Yeah. Hello everyone. Today we will start with LLM and benchmarks part 2, LPAC ever, unveiling the secrets of strategic reasoning in language models. In the ever evolving landscape of artificial intelligence, one area has remained elusive, truly understanding strategic reasoning. While language models can excel at tasks like question answering and summarization, mastering the intricacies of game playing and strategic decision making has proven a formidable challenge. This is where Alpac Eval enters the stage not as a competitor but as a crucial benchmark and evaluation framework designed to access and advance the capabilities of language models in strategic reasoning. Unlike traditional focused on factual language understanding, Alpac Ever presents complex scenarios inspired by classic games like chess, Go, and StarCraft. But here's the twist. It translates these strategic puzzles into text-based descriptions, making them accessible for effective evaluation of large language models. Okay. Now, what make Alpac Ever tick? Alpac boasts a diverse range of tasks that test various aspects of strategic reasoning. Planning. Can the LLM formulate optimal action sequences based on the current state and potential future outcomes? Opponent modeling. Can it accurately predict the opponent's moves and counter strategies? Long-term reasoning. Can it consider the far-reaching consequences of actions and assess trade-offs between immediate gains and future benefits? Contractual reasoning. Can it imagine alternative scenarios and the impact of different choices? But how do we know it works? Path employs a combination of human evaluation and automatic metrics to generate comprehensive assessments of LLM performance. This ensures that models aren't merely exploiting linguistic loopholes but genuinely understand the underlying strategic concepts. Impact and beyond. Since, since its inception in 2019, Alpaca Evil has become a cornerstone for evaluating and advancing the capabilities of LLMs in strategic reasoning. It has fostered research in areas like natural language processing, developing robust methods of parsing complex game descriptions, and reasoning about abstract entities. Multi agent reinforcement learning, designing algorithms that can learn and adapt strategies within dynamic competitive environments. Explainable AI, understanding the reasoning process of LLMs playing strategic games, ultimately leading to more transparent and trustworthy AI systems. The future unfolding. The creators of Alpac are actively expanding the benchmark with new games, tasks, and evaluation metrics. Additionally, research efforts are underway to incorporate visual elements and real-time interaction into the framework, pushing the boundaries of LLM capabilities even further. Join the quest of strategic AI. By exploring APAC L, you are not just witnessing the evolution of AI, you are becoming part of vibrant community dedicated to unlocking the secrets of strategic reasoning. Here are some ways you can engage. Dive deeper into specific tasks, analyze the design, challenges, and evaluation methods of individual impact level tasks. Compare with other benchmarks. Discuss how Alpaki will position itself within the landscape of game-playing AI benchmarks, explore ethical considerations, reflect on the potential implications of developing AI systems capable of strategic reasoning, predict future applications. Imagine how advancements in strategic AI could impact diverse fields like robotics, economics, and even game design. Remember, a Pack Evo is not just a technical framework, it's a gateway to a future where AI can reason, strategize, and navigate complex scenarios with the same brilliance that we do. So, step into the arena, sharpen your analytical skills, and join the quest for strategic AI. The overview can be further enriched by providing real world examples showcase how APAC-EVAL is just used to evaluate specific LLM architectures or algorithms. Analyzing special tasks, delve deeper into the design and challenges of individual tasks like planning or opponent modeling. Discussing ongoing research, highlight recent advancements and future directions in strategic AI research inspired by APAC-EVAL, offering resources. Share link to the official Packable website, research paper, and community forums. Encouraging collaboration. Invite readers to contribute their own ideas and expertise to the ongoing development of LPAC Evil. By crafting a compelling narrative that blends technical explanations with real world examples and a call to action, you can transform this informative overview into an engaging invitation for anyone interested in exploring the fascinating world of strategic AI and its potential to revolutionize the way we interact with technology in the future. Let's make a deep dive into common sense reasoning benchmark. Harassment might sound like a sassy fashion statement, but in the world of AI research, it represents a challenging benchmark dataset designed to test language models' ability to reason with common sense knowledge. Imagine a world where an AI not only understands words and grammar, but also the unspoken rules and nuisance of everyday situations. That's what Healthwack strive to access. Here, what makes Healthwack unique? Focus on common sense reasoning. Unlike traditional language models that excel at factual like tasks, Healthwack focuses on scenarios requiring common sense reasoning and understanding of everyday situations. For example, predicting what happens next in a kitchen scene based on available ingredients and tools. Adversarial generation of wrong answers. The dataset includes not only the correct answer to each scenario, but also three carefully crafted, human validated adversarial wrong answers. These distractions, designed to mimic human errors in reasoning, make it harder for models to simply rely on pattern recognition or statistical correlations. Multiple domain and task. LSVAC spans two common domains, ActivityNet and WikiHow. This diversity challenges models to generalize their reasoning skills across different types of information. High human accuracy. For humans, LSVAC questions are surprisingly easy, with an average accuracy of over 95%. This highlights the difficulty of training machines to achieve similar performance, further emphasizing the importance of common sense reasoning in AI development. Beyond benchmarking, Hellas' contribution extends beyond simply texting existing language models. It has fueled research in several areas, identifying weakness in current AI models. Studying models' mistakes on LSWAG helps researchers understand where common sense reasoning capabilities are lacking and how to improve them. Developing new training methods. The adversarial nature of the data sets has motivated the creation of new training algorithms that can better handle ambiguous and misleading information. Understanding the nature of human reasoning. Analyzing how humans and machine approach heliocentric tasks shed lights on the cognitive process involved in common sense reasoning, which can inform future AI design. Let's deep dive into truthful QA, measuring truthfulness in language. In the bursting realm of artificial intelligence, where language models weave intricate tapestries of text, a crucial question arises: can we trust them to the truthful? Enter Truthful QA, a unique benchmark and evaluation framework designed to assess the veracity of language model responses. The stakes are high, as language models play an increasingly prominent role in our lives, from generating news articles to assisting with research. Understanding their tendency to mislead or disseminate information becomes paramount. Truthful Query tackles this challenge head on by providing a rigorous platform for evaluating their adherence to factual accuracy. The intrinsics of Truthful Query. This benchmark isn't your typical multiple choice quiz. Truthful Query present language models with complex scenarios where false beliefs, biases, and incomplete information lurk around every corner. These scenarios, inspired by real-world situations, test the model's ability to distinguish fact from fiction. Can the model differentiate between established knowledge and personal opinions or unsupported claims? Reason under uncertainty. Can it navigate situations with ambiguous information and avoid drawing unwarranted conclusions? Resist manipulative tactics. Can it handle loaded questions and misleading prompts without sacrificing factual accuracy? Evaluating performance. Truthful QA doesn't solely rely on human judgment. It employs a hybrid approach combining human evaluation. Experts assess the truthfulness and plausibility of model responses in various scenarios. Automatic metrics. This matrix analyzes linguistic cues and factual consistency to provide further insights. By combining these measures, Truthful Query generates a comprehensive picture of language models' truthfulness tendencies, highlighting its strengths and weakness. Impact and future towards vacuous AI. Truthful Query is already making waves in the AI community. Researchers are actively utilizing it to improve language model training, identify areas where models are susceptible to biases and information, informing the development of training data sets and algorithms, develop explainable AI systems. Understanding why models make certain claims can help build trust and transparency in the decision making processes. Foster robust communication. By equipping language models with better truth detection capabilities, we can pave the way for more reliable and trustworthy interactions between humans and AI. The future of truthful QA is bright. Researchers are continuously expanding the benchmark with new scenarios and evaluation methods. Moreover, its principles are inspiring the development of similar frameworks for the other AI tasks, pushing the boundaries of trust and reliability in the realm of artificial intelligence. Vinograde. Demystifying the Vinograd Schema Challenge. The Vinograd Schema Challenge WSC is a benchmark test used to assess the ability of language models to understand common sense and context. It's named after Terry Winograd, a computer scientist who proposed the test in the 1970s and served as a crucial stepping stone towards truly intelligent AI. The test structure WSC challenge consists of multiple choice questions featuring sentences with pronouns whose reference can be ambiguous depending on the broader context. For example, the trophy room was full. A. Bill polished the trophy carefully. B. The maid dusted the trophies carefully. In this case, both Bill and the maid could have polished the trophy. However, understanding that a man typically couldn't be dusting trophies reveals that option A is the correct answer. Vinograde dataset. This dataset, inspired by the WSC, expands on it by presenting thousands of similar questions across various domains and linguistic structures. This variety tests the model's ability to generalize its reasoning skills beyond specific scenarios. Challenges and significance. WSC and data sites like Vinograde poses significant challenges for language models. Simply having a vast vocabulary and understanding grammatical rules isn't enough. Models need to reason about the real world, draw inferences from context, and understand the relationships between entities and actions. Successfully resolving these challenges would mark a significant advance in the field of AI. It would indicate a move towards truly intelligent machines capable of understanding language not just literally but also in its deeper contextual meaning. Applications and implications. Mastering Vinograde and similar tests paves the way for numerous real world applications. Machine translation systems that account for context could offer more accurate and nuisance translations. Conversational AI could engage in more natural and meaningful dialogues. Understanding the intended meaning behind user queries, automated summarization tools could capture the essence of text, not just the surface level keywords. However, ethical considerations arise with the development of such powerful language models. Potential biasness within the dataset, for example, could be inadvertently amplified, leading to unfair or discriminatory outcomes. Therefore, careful development and ongoing evaluation are crucial to ensure responsible and inclusive applications for this technology. Deeping deeper into Vinograde, unmasking common sense reasoning in AI. The Vinograde Schema Challenge and its offspring, Vinogrande, are more than just intricate quizzes for language models. They are gateways to understanding natural language processing (NLP) and artificial intelligence (AI) on a deeper level. So, buckle up, language explorers, as we delve into the heart of common sense reasoning and see how these challenges eliminate the path towards truly intelligent mass machines. The quote of WSC. Imagine a sentence like, the trophy room was full. A. Bill polished the trophy carefully. B. The maid dusted the trophy carefully. Both options grammatically fit, but only one makes sense given the context. WSC focuses on these aha moments where understanding the real world situation becomes crucial for choosing the correct pronoun different. This requires the model to grasp implicit knowledge. Beyond the literal meaning of words, WSC proves the model's ability to understand unspoken assumptions about the world. Reason about trophies. Models need to connect entities and actions. Recognizing the policy, polishing a single trophy aligns with build, but dusting multiple trophies with made. Infer context with limited information. The challenge lie in extracting enough meaning from the short provided context to make a logical choice. We know Grande, expanding the horizon. While WSC paved the way, Vino Grande takes the test to the next level. With over 44,000 questions covering diverse scenarios and linguistic structures, it pushes the boundaries of AI comprehensions. Consider this. The city council had approved a new tax. A. A. The mayor was very angry about it. B. The residents were very angry about it. Here it could refer to the text. Here it could refer to either the tax or the council's decision. Vinogrande process models to understand not just the sentence itself but also the broader context, including social dynamics and potential motivations. The significance of WSC and Vinogrande successfully tackling these challenges has profound implications for machine translation. Imagine translation that captures not just the words, but also the nuisance of cultural references and implicit meanings. Conversational AI. Envision chatbots that engage in natural and meaningful dialogues, understanding your intent and responding with accurate and relevant information. Text summarization, tools that go beyond summarizing keywords and capture the essence of a text, including its underlying context and implications. Challenges and ethical considerations. Despite its potential, mastering WSC and Vinogrande presents significant hurdles. Data set biasness. If the training data contains stereotypes or prejudices, the model might reproduce them, leading to unfair outcomes. Explainability and transparency. Understanding how models arrive at their decisions is a crucial for building trust and addressing potential biases. Generalizability across domains. Can model trained on specific scenarios apply their reasoning skills to entirely new situations? Addressing these challenges demands responsible development and ongoing evaluation. We must ensure that AI advances alongside with ethical considerations, promoting inclusivity and fairness in its applications. ARC, unlocking abstraction and reasoning in language models. The abstraction and reasoning corpus, ARCC, is a challenging benchmark data set designed to access the ability of language models to perform abstraction and reasoning over factual common sense and abstract knowledge. Compared to traditional language, understanding tasks like question, answering, or summarization, ARCC pushes the boundaries by requiring models to go beyond surface level comprehension and delve into the deeper meaning and relationships between concepts. The data set structure. ARCC comprises multiple choice comprehension questions in three categories: factual reasoning, questions requiring inferences based on provided factual information; common sense reasoning, questions testing understanding of everyday scenarios and social norms; abstract reasoning, questions involving abstract concepts and logical relationships. Each question features a passage of providing context followed by five answer choice and an explanation for the correct answer. This detailed structure allows for fine-grained evaluation of the model's reasoning process and identifies areas where it might falter. Challenges and significance. Mastering AI presents significant challenges for language models. They need to go beyond simply matching keywords or patterns in the text. Instead, they must identify and extract relevant information from the passage. Reason about the relationship between entities and concepts. Apply common sense knowledge and understanding of logical rules. Make inferences and draw conclusions based on the extracted information. Successfully demonstrating these abilities would mark a major leap forward in AI research. It would indicate progress towards building truly intelligent machine capable of independent thought, logical reasoning, and creative problem solving. Current performance and future directions. While initial results on RCC are promising, significant room for improvement remains. Current state of the art models still struggle with certain types of questions, particularly those involving complex abstract reasoning or challenging social dynamics. Ongoing research focuses on improving reasoning capabilities in language models through various approaches, incorporating knowledge graphs and external factual databases, developing more sophisticated representation, learning techniques that capture relationship between concepts, utilizing meta-learning and reinforcement learning to improve the model's ability to learn and adapt to new reasoning tasks. The ultimate goal is to create language models that cannot only understand language with human-like accuracy, but also apply that understanding to reason, draw conclusions, and make logical decisions in any context. Delving into the depths of reasoning from LLMs. The discrete reasoning over paragraphs drop benchmark presents a unique challenge for large language models, and pushing them beyond more factual recall and towards complex reasoning with diverse information. So buckle up as we deep dive into the traces of drop and why it matters for evaluating LM capabilities. The test structure. Drop datasets like DROP and GSM-8 comprise multiple choice comprehension questions based on paragraph length passages. Unlike typical question answering setup, DROP questions test discrete reasoning steps, forcing the LLM to identify relevant information within the passage, apply logical operations and inferences, reason about relationships between entities and concepts, choosing the most accurate answer from multiple plausible options. The question come in various flavors and covering. Ordering. Arrange events in chronological order. Counting. Determine the number of entities actions mentioned. Comparison. Identify similarities and differences between entities. Classification. Categorize information based on provided criteria. So today we will just stop the session till here. Next Saturday we'll again continue. Okay, we will deep dive into this concept. Okay, Cla. Bye.